Okay, everyone, and now we are going to be continuing on with answering the question that we covered in the previous video. This is part two to the 14th video. And so please make sure that you pay very close attention. If you haven't already watched the first video, you cannot continue on with this video if you haven't watched part one. If you haven't watched part one, make sure that you click in the description. There's a link that I've placed in the description below, and it will direct you back to video one, part one. Okay. And so remember everyone, this is very important to remember. Now this question tests your knowledge and your understanding on a deeper level. It's not a surface level question. And so we need to expose ourselves and challenge ourselves with questions that we aren't used to. Okay, we need to challenge ourselves with the questions that we don't normally incorporate into our file. A lot of people do create a file that they use in order to practice for their math exam. Okay, so you need to incorporate this into your studying methods or processes. Okay, and so now without further ado, make sure you pay very close attention and let's continue on. Now, question 10.1, by the way, I will not be explaining how I got to the annotations. I've explained that in part 1. 10.1, we have to prove that MQA is similar to MBQ. Now, before continuing on, what does it mean to prove that two triangles are similar to each other? Well, I'm pretty sure we're all familiar with that. I will not backtrack to that, all the way back there. But, well, this is the method I want everyone to use. This is incredibly effective, okay? So, the very first thing that you want to do is you want to identify if M is equal to M. So MQA in M, or M in MQA, is M in MQA equal to M in MBQ? So there are a few set of questions that you have to ask yourself, okay? And so now, before continuing on with that, I'm just going to highlight the two triangles that we are currently working with, okay? So MQA would be this triangle over here, MQA, okay? And MBQ, the orange triangle here. Now, is M in MQA, which is this angle over here, M1, is it equal to M in MBQ? M in MBQ is also M1. And so we can clearly see that they have an angle that they have in common. You can clearly see now a lot of students actually, they conflate this whole idea. They are, they do experience a sense of confusion when approaching, this type of question, not even this type of question, when approaching the method where you would state and verify that two angles are equal to each other because they're at a common point. Why do I say that? Well, let's pay very close attention. So I'm just going to label this triangle ABC. And we have another triangle, a smaller triangle within ABC. And we'll label this triangle ZDC. And so we can clearly see that they share the exact same vertex. The vertex would be this part over here. It's the point at which both sides of the triangle meet, right over here. And so this would be accurate. It would be accurate if we said that both triangles share an C. Okay, they share that exact same point. Now the same thing applies to MQA and MBQ. They share the exact same vertex. They share the exact same angle, which so happens to be M1. And so now we already have that point fixed. We've already proved that M in MQA equals to M in MBQ. Now, before continuing on, by the way, I will refer to the memo in just a minute. I just want to explain a few things. Just want to do a little, brief overview before we continue on with reading the memo. Okay, now, Q in MQA, that's Q1. Now, is Q in MQA, which is Q1, equal to B in MBQ? Okay, so MQA. So MQA, Q in MQA is Q2 and Q1. And then B in MBQ is B1. So is B1 equal to Q2 plus Q1? Or we haven't marked them off as being equal to each other just yet. And so we're just going to leave that off for last. We might come back to these, the pairs of angles that we identified. We might have to come back to that, okay? Now let's continue on. What about A in MQA? So MQA, A in MQA is A1. MBQ. Now, is A1 equal to Q in MBQ? Q in MBQ is Q1. So is Q1 equal to A1? We've marked them off as being equal to each other. Why is that? Well, that was because of the tan chord theorem. So please refer back to the other video if you did not understand that. So we can clear, that's why it's very important to just mark off um, angles that are equal to each other with corresponding colors. So we said A1 equals to Q1 because of the tan chord theorem, and just like that, we proved that those two triangles are indeed similar to each other. So you first want to state the fact that M1 equals to M1 because they're common, and A1 equals to Q1 because of the tan chord theorem. And by the way, when we're looking at the last two angles, so we also have a pair of angles that are remaining that were a part of both of the triangles, they automatically equal to each other because of the remaining angles of a triangle or sum of angles of a triangle. Therefore, triangle MQA is similar to triangle MPQ because of angle, angle, angle. Now, before continuing on, the minute that you've proved two triangles are similar to each other, I strongly suggest that you write down their ratios. Okay, so I'm going to write down the ratios. 10.2, we have to prove that mr to the power of 2 equals to am multiplied by mb. Now, a lot of students are completely horrified by these questions, these question types. They dread it. They have a severe, they have severe PTSD when it comes to these questions where you see a square root, and then on top of that, in addition to that, you have an equation, and in addition to that, you have two lines that are the product that are being multiplied with one another. Now, a lot of students approach this with fear. However, I'm going to tell you, I'm going to show you something that is incredibly easy. Okay, so now this ties back into what I said previously. Now, here are a few steps that you have to follow when you are required to prove a certain ratio that includes a root. The very first thing that you have to do is you have to pay attention to the ratios that we've proved previously. So just create a list. The next thing that you have to do is you have to use similar triangles. The next thing that you can try to do is you can try to use your midpoint theorem if it is applicable. The next thing you could try and do is you could use your prop theorem, or you could try to use Pythagoras or trig. So I would like for everyone to write down this list for themselves. Now, the reason why I highly suggest that you write down a list for yourself is because it allows you to open up your mind to exploring different options that might be applicable for this question. And so what happens is your anxiety is relieved, and now you're approaching it with strategy, and you're not just randomly, picking and choosing any topic that comes to mind. When you approach a math exam, you need to approach it with a prepared mind, not an unprepared mind. And so we are ready to explore all the different trigonometric, not even trigonometric, any principles or theorems that might be applicable to this question. Now, the very first thing, or the very first strategy I do suggest that you use is the ratio strategy. And so if you've proved that two triangles were similar to each other in a previous question, I want you to identify if any of the lines that are a part of this equation were a part of the ratios that you've created. So we have MR, AM, and MB. Okay, so we have MR. MR is not present in this question. What else do we have? We have MR, AM, MB, AM. Okay, so we have AM and MB. Okay, so now, do you think MB, MA, do you think these two ratios, and by the way, when you are selecting your ratios, you have to select two pairs of fractions, okay? You cannot just select one, fraction. That makes absolutely no sense. You need to select a pair. Okay, so a pair, which obviously includes MQ over MB, we've identified MA, and we've identified MB. And so remember, we're trying to prove that MR squared equals to equals to AM multiplied by MB. However, there's an issue. We have AM and we have MB, but instead of there being MR, we have MQ. So now what do? Let's pay attention to the position that MQ is in, the position that MQ has in the diagram. And so MQ is right over here. Okay, so we can clearly see that MQ actually equals to MR. Why is that? Well, remember, we've marked this off previously. So remember, we said that, well, we've noticed that QM and MR are tangents, and since they meet at the exact same point, they're all equal to each other. They're equal in length. However, on the memo, they've actually, they've used a different method. You could use this method that I'm showing you as well, that I've showed to you as well. And so if MQ equals to MR, you could just replace that part with MR since they're equal to each other. However, on the memo, they took a very different approach. You can use this method that I just showed you right now. However, I would like to explain to you how this question was covered and answered using the method that is shown in the memo, okay? And so now the method that we used in the memo was the second method or the second option that was on our list, proving that two triangles are similar to each other. And so now when you're selecting the two triangles that you intend on proving are similar to each other, you need to pick two triangles that both have line MR. Why is that? Well, because if you have an equation that has an exponent of 2, it probably means that MR was multiplied with itself twice. So probably means we had So it probably means we had MR multiplied by MR. So we want to identify two triangles that both have MR. So this triangle MBR has MR in it. So MBR, okay. And what other triangle has MR? The MAM. This is AMR. AMR is a triangle that also includes line MR, and so we want to highlight that. Okay, so we've identified two triangles that both have line MR. Now, the next thing that we have to do, the next step to the process would be to prove that they're similar to each other. Please remember that, just because they both have line MR doesn't necessarily mean that they are similar to each other. Now, how do we prove that they're similar to each other? Well, the very first thing that you want to do is you just actually want to write out the name of the triangle. So, MAR. We're going to label this triangle as MAR. Okay, so you're just going to write that down as triangle MAR and MRB. MAR, MAR, MRB. Okay, so remember, the way that you label these two triangles has to correspond with the angles that are equal to each other. And so we can clearly see that M2 and M2 in both triangle M in MAR is equal to M in MRB because they're common. They share the exact same vertex. They share that exact same point. They have that angle in common. And so that's why we want to label the very first part of the triangle. The name of the triangle has to start with M for both triangles because M in triangle MAR is equal to M in MRB. Now, let's identify other triangles that are equal to each other. We can clearly see, I don't know if you can see this, but we have, I've marked off R1 as being equal to A2 because of the tan chord theorem, okay? So we said A2 equals to R1 because of the tan chord theorem, and the remaining angles were automatically equal to each other because of sum of angles of a triangle. And so just like that, very easy, very simple, we've proved that those two triangles are similar to each other. And just like I said previously, well, remember, what was the entire purpose of us, proving that these two triangles were similar to each other? Well, the entire point was so that we can prove this ratio, so that we can manipulate the ratios in such a way that we would get this equation. And so the minute we've proved that they're similar to each other, you want to write down the ratios. AM over MR equals to, by the way, you have this in press, so it's usually MA over MR equals to AR over RB equals to MR over MB, but you want to select the two fractions that includes MR, AM, and MB. And so when you cross multiply, MR multiplied by MR is MR squared, AM multiplied by MB is AM multiplied by MB, and that is incredibly simple. And a very simple approach to the question, to solving this question. Continuing on, 10.3. Now, we have to prove that MQ to the power of 2 over MR to the power of 2 equals to 1. Now, A lot of students, just like I said previously, just as I stated previously, are very intimidated by these questions. Okay, they become very dysregulated. Their focus is deterred because of the amount of fear that they're experiencing upon looking at this question or upon reaching this question. I'll show you exactly how easy it actually is. So what I want you to do is I want you to pay very close attention to what I said previously. So remember, I stated that you have to create a list that you have to follow or that will serve as guidance in dealing with these questions. We have mq squared and mr squared. Remember, in the previous question, we proved that mr squared equals to am multiplied by mb. And in question 10.1, we've written down our ratios that we were able to construct as a consequence of us proving that two triangles were similar to each other. And so we had MQ over MB and MA over MQ. So if we select these two fractions include MQ squared, and MQ squared is a part of the ratio that we are attempting to prove. And so if we cross multiply using just these two triangles, we will get an answer of AM multiplied by MB and MQ multiplied by MQ is MQ squared. And so now what do we do? And by the way, when you write these ratios down, you need to give a reason for your answer. Your reason for your answer has to be similar triangles. So you're just going to write that out in brackets, similar triangles. You cross multiply, leaving us with an equation of mq squared equals to mb multiplied by ma. However, we also have mr squared equals to am multiplied by mb. And so what we want to do is we want to take mq squared and divide mq squared with mr squared. Remember that mq squared's equation is equal to the mb multiplied by ma as clearly stated over here. Okay, and mr squared also equals to am multiplied by mb. Okay, so when we divide these two fractions with one another, or when we not the fractions, when we divide mq squared, remember mq squared's value is mb multiplied by ma, and we also divide that by mr squared, and mr squared equals to am multiplied by mb. Now we can see that a few line segments cancel out. They cancel out because they're identical. Now when everything cancels out, we're left with a value of 1. And so that means that mq squared over mr squared equals to 1, and that's exactly how we're going to conclude our answer. That's exactly how we achieved and calculated our answer and proved this equation with sufficient information. Okay, everyone, hopefully that video was incredibly helpful. And please do keep in mind that these question types aren't always asked in your exam. However, when they are asked, they constitute a tremendous amount of marks, many marks. They constitute many marks of your total exam paper, and it's very important to understand how to approach these questions. And so if you don't know how to approach these type of questions, if you lack the skills in answering these questions, you will fail catastrophically. Okay, and as a result, you will probably end up losing 30 marks. Okay, and we do not want to lose 30 marks. That is an incredible amount of marks. Now, in the next video, I'll be covering some more commonly asked exam Euclidean questions, so stay tuned for the next video.